Because right now, what they get to is they get a backend, so the actual users of the game can have weight to their.
Oh, the server wrong.
All right. All right. What we're gonna do is we're gonna look at here. Wait, my computer's not working. Great.
He's gonna learn to do
Yeah,
Oh, why? Is there
now all the time. But that's a lot. There's no way they can. How's it? Maybe.
You were left out because you were angry and you got left out of the house.
No, HDMI is not connected. It's connected through Wi-Fi.
Maybe.
All right, so guys, we got things to do. Thank you. Let's go. So we're gonna talk about a couple situations. One is we're gonna tell you when to stop, right? So you guys need to know when you should stop on the DI method. So I will say DI method, you stop. You stop when the first thing is when the derivative go to 0. Goes to 0. Or if you have potential to go to 0, you want them to go to 0. Okay, so you want to see if they have potential to go to 0, you want to see them go to 0. You don't want to go horizontal. Okay. 2, you stop when the horizontal is the horizontal line is horizontal multiply together is integratable. Is integratable. Third, when the horizontal is same as the questions. And we're gonna explain that. When is horizontal is, this is I call that the cyclic situation. So that means everything gonna go in cycle and it's gonna go infinite if it doesn't stop. Okay, so this is when do we do certain things? So I'm gonna start with this first question. The first question is gonna be x to the fourth ln of x dx. Okay, x4 ln of x dx. Now we're gonna try DI method here, and we're gonna see when do we stop. Which situation is this? What do I set ds? ln of x. Okay, so plus minus plus. This is ln of x. Now, what's the derivative of ln of x? 1 over x. Does that have potential to go to 0? No, if I keep on taking derivative, it's going to get x to the -2, x to the -3, and so on and so on. The sign's going to alternating, so it's not going to go into a 0. But when it's I here, this one's going to be x to the fourth. What's the integration of x to the fourth? x5 over 5, right? Now, if you see this here, that is integratable, because if you multiply together, and that's just still x to the multiple power, so it's just power rule. So that becomes integratable, so you stop. So what do you mean by stop? So you're going to write out like, well, x to the fourth, no, sorry, it's going to be ln of x times x5 over 5 minus, so now integratable, you're going to say, well, what's integrate of this? So it'd be minus integration of 1 over x times x5 over 5 dx. Is that okay? So x5 over 5 ln of x minus 1 over 5 x to the 5. So that's x to the 5 over 5 ln of x minus 1 over 25 x to the, no, sorry, this is 4. This is x to the 5 plus c. Yes.
So, I mean, I know it's not for this question, but like, just so I understand, if we were to start like from the second row, like it goes minus, then it would be x to the fifth over 5 ln x, but that's negative instead. And then when we do the diagonal down to the horizontal, that would be positive then? Like if we were to start from.
So are you saying if there was information after here?
Yes.
Okay, so we're gonna get there when we see it. But right now we don't see it, so we see integratable, we integrate it. You don't wanna overcomplicate it. When you see integratable, so we have the second situation, it's integrable, we're just gonna integrate, boom. Okay, so we're gonna give you a situation that where is the derivative go to 0. So the derivative goes 0, you should see the pattern of recognizing it's like this. It's like this. It's gonna go straight down. So we're gonna have a sign in natural log. So in this case, we're gonna have this, and the integrate of this. Is that okay? Okay. Now the next case that we have is integration of x squared sine of x. Did we do this one yesterday or no? No? Okay, so we can try to do this one.
Did that video help you guys or not?
We're trying to, we had a back.
Yeah, I've seen a video. In Xamarin, it had its own memory. That could persist there. We don't have a back. Yeah, that's the main problem. We don't have a backend file. And like, their version is on Firefox, Google, and Google like age restricted in Florida. So
but I'm saying you have to do both.
Wait, Google's age restricted?
for AI to make sense.
Oh, yeah.
But that is gonna be a repeat.
So you're trying to change the back end completely. That goes to the, yeah, that's the problem. It's a like,
2x.
that doesn't have the back end.
Yeah, so no, yeah, okay, so this goes to 2.
I mean, I know what they're talking about. It's nine,
This
too.
goes to negative.
it everything.
And I remember
Everything
the
after.
we try to
troubleshoot that first and then keep going?
I don't think you can fix that.
The integration made it.
Yeah. It's like this is integratable, right? Like here when we did this.
Wait, and you do.
That's fine. Write it out. Multiply.
You only integrate it if you
Okay, do you have this part? I go all the way to if I have option to go to 0, I'm gonna go to 0.
You go, you just
minus.
rotate with positive and negative.
Minus.
Yeah, so the sign is gonna be positive, negative. So it doesn't matter what happened here, because the path is gonna going like this. If we go into 0, it doesn't matter because 0 is gonna multiply. It's gonna be gone. So it doesn't matter what this term is. It doesn't matter what this term is because it's still 0. So if you go into here, that's gonna be 0. Yes.
The derivatives. Oh, it's integration.
Yeah, that's the integration. Yeah, sometimes it's really easy to confuse. So you gotta pay attention that you're doing the stuff correctly. So I'm gonna first line. I'm gonna follow the red path. It's gonna go here, here. So that's equal to negative x squared cosine of x. Is that okay? And then go here, here. So it'd be two negative signs. So it's gonna be positive 2x sine of x. Is that okay? And last one is gonna be here. So that is gonna be plus 2 cosine of x plus c. And that's it.
You don't integrate anything again. You only integrate if it's horizontal.
Yeah, you only integrate when it's horizontal. But if we go to 0, even though a lot of times people says, hey, Mr. A, this is integratable. But if we go to 0, you prefer to go to 0 because all you gotta do is write it down like this. You don't even have to do anything. You just keep on writing until it stops. Okay. You want to try again? Okay, let's try the same thing again. We're gonna tell you like, so this, if you have option to go to 0, you let it go to 0. We're gonna try pretty much the same problem, but it's a different number. But you gotta be careful integration of sine of 4x. So.
Misha, you know how to code?
I'm not great.
What's broken?
Our back end.
Can you code back in?
Don't worry, I never said speak like this. What is this? What is AI?
Negative cosine 4x.
Connected to school Wi-Fi. Kind of like his video restricted through your phone there. No, even if you had school Wi-Fi. Kids are using their filter data. But
That's it.
Just like a signal block. Signal block over here.
yeah, they did.
There's such a thing as signal
Sometimes
block.
we're not integrating.
Oh, Node. Node was the back end. I thought it was like a regular thing. So what I had originally thought was Node was a version of a Visual Studio, but it's a version of Fire.
But yeah, like I said,
Okay, so
So we were in the right direction.
Yeah, you guys are right.
Not completely.
So that's why when you guys download Node, I was like, I remember watching these videos about it. He was using no, but the guy knows how to use AI agent. That's why I'll ask you a question. I was like, what is AI agent?
It's one of the.
Positive, right?
Another side, right?
No. If it has a negative one, it should leave.
Remember, integration sine of 4x is not 4 something, it's 1/4. Okay.
Do you guys know about integration by part?
Oh,
So this application uses serverless / peer-to-peer.
You know what I got?
Yeah, no, they don't.
The database.
Still makes me laugh.
Firebase, I get.
Yeah, Firebase runs actually the database and the Google Cloud, the cloud.
Okay, so first of all, when you integration something, it does not give you 4 cosine of 4x. It's actually 1/4 because u equal to 4x. So those are things you have to be cautious. But I can do it inside my head with the u substitutions now after we go through calc 1, calc AB again, and calc BC. So now we say, oh yeah, that's u substitution, just going to be 1 over a, 1 over that value. So now I just have to line up. I just say, hey, that's equal to x squared negative 1/4. So it'll be negative 1/4 x squared cosine of 4x minus and the minus is going to be positive 2 over 16, so it's 108 x sine of 4x. Is that okay so far? And a plus 2 over 64, so it's 1 over 32 cosine of 4x plus c. Okay, so now we're going to talk about cyclic. Cyclic is really hard for you guys to see, but remember the L, I, A, T, E. When you have a combination of T and E, I'm going to say that again. When you have a combination T and E, usually it will become cycle because the derivative of the trig function is going to be cycle. Derivative of e to the x is also cycle. So they both cycle together. It actually doesn't help you. It doesn't go to 0 because you can take a derivative infinite amount of time of sine of x, it doesn't go to 0. You can take a derivative e to the x, does not go to 0 because it becomes e to the x. So then when you have this combination, that usually leads to cycle. And sometimes if you just have L and I, you can just do integration by part by itself. Like for example, natural log of x dx, and for example that is gonna be, you have to think about it's 1 times natural log of x or 1 times the sine inverse of x, right? So you have to know that's 1 next to it, so they can be by itself. Yes.
Is that why both T and E are like at the end?
Yes, because they are cycle, and they are the last priority. They are the worst part. So let's see that the worst situation happened. When the worst situation happened, that's gonna give you something that says integration of e to the 2x sine of x dx. Now, with this type of question, I will write down the question, and I'm gonna do is take a marker and throw it at it. No, I hate Bennett. Because if I stop talking, if I realize every time I stop talking, Bennett wake up. So I just keep on talking and I stop. Because every time I realize this, Bennett knows that Brendan is like, if I stop talking, that means I'm getting ready to take a marker and hit him. So I have to keep on continuous talking.
This year you should start like whacking people with ping pong balls. Like have a paddle and set up there and watch.
Yeah, but I'm gonna miss.
It's good practice then.
Yeah, that's good practice.
It is good practice.
I'll be Marty Spring by then. Right?
I'm gonna visit 36 my sophomore year.
All right. So now I have LIATE, but T come before E. So therefore, I'm gonna do D. I'm gonna do here D I and then plus minus plus, right? So D is gonna be what? Sine of x or e to the x? Sine of x. Okay, because that's sine of x. Now what's derivative? Well, that's cosine of x. And what's derivative cosine of x? It's negative sine of x. And minus, and that's what's derivative negative sine of x? Cosine of x. Okay. Negative cosine of x. Thank you. Okay. So now I'm going to integrate e to the 2x. Now be careful when you integrate e to the 2x. What's the integration of e to the 2x? E to the 2x, what? Over 2. Thank you. So it's 1/2 e to the 2x. Because integration, I'm going to do this on the side. E to the 2x dx. U equal to 2x. Du equal to 2 dx. And the du over 2 equal to dx. So that'd be e to the u, du over 2. And that's where the 1/2 come from. But that's a longer way to do something. I don't want to do that anymore. So from now on, you guys can figure out the next one's going to be 1/4 e to the 2x. And 1 what? 8 e to the 2x. Now, you're going to realize, when do I stop? Do I stop at first line or the second line or third line or the fourth line?
Fourth line, it starts to recycle.
You don't start at all.
Where do I stop?
One
Oh,
end.
shit.
Where do we
When it's
stop?
same as original.
Same as original. Well, which line is same as original? The sine of x. Good. Is this part is the same as original? You stop right there.
What?
It's a 1/4.
It doesn't matter. At 1/4, it's just a constant. But far as the sine of x and e to the 2x, exactly the same. So this is no longer needed. Boom, gone. So I stop there. So why do I stop there? Because if I don't stop, I'm just gonna keep on going. There was no end inside. Yes.
The negative sine of x it doesn't matter if it's negative.
Because you can factor it out.
You can. It's a constant. If it's constant, doesn't matter. Okay, so constant doesn't matter, because therefore they're not ever gonna be the same if there's you worry about constant. So now I'm gonna write it out. So I'm gonna do a. So I'm gonna write out here. Pay attention. Why do I write it here though? I'm gonna say that's gonna be 1/2 sine of x e to the 2x. Is that okay? And the minus 1/4, right? Minus cosine e to the 2x cosine of x. Is that okay? Am I doing okay? I double check. Okay. Now I'm gonna do minus, and I'm gonna code it the same color as the question. Sine x, right? And 1/4, right? And the e to the 2x dx. Does that make sense? Now, why do I code it as a black? Why do I do this? Why does that help me solve the problem?
It's stuff integrated.
What Nelly say? What Nelly say? Can you say out loud? It's a like term.
Oh my gosh, I hate that.
So if it's a like term, right? So this and this are like term. And this is a like term. So can I go with 5/4? Why is 5/4? So 1 plus 1/4, right?
Oh, because you're
E to the 2x sine of 2x, the sine of x dx is equal to 1/2 e to the 2x sine of x minus 1/4 e to the 2x cosine of x. So now, in order to get the integral, I can just isolate this. So what do? Times 4/5 on both sides. So therefore, integration e to the 2x sine of x dx, you times 4/5 to cancel 5/4, right? So 4/5, so it'll be what? 2 over what? Sorry, it's 2/5, right? Wait, I cannot do math right now. 1/2 times 4/5. So that is equal to 2/5. So e to the 2x sine of x, right? Minus, what's the other one? 1/5?
1/4.
1/5.
Uh,
Plus c. Don't forget the plus c. So cyclic is, it becomes like you have to utilize the original question and you had to see this and you had to move back to solve for the actual thing. I think this is the hardest one. Now this one is less likely to be on AP exam, but it's been there, but it's less likely. All the DI method, all other one is the one that were more likely to be on it, but this is the one of the harder one. Okay? Now what I'm saying is, now we got some situation. How about definite integral, right? Remember, we also gonna talk about this situation. We talk about L, which is integration of natural log of x. Now we're gonna talk about, hey, what's integration of arc sine of x dx? And now we can also now, I'm gonna add something in there, is the boundaries. So here's the hint on the boundary. The hint on the boundary is you're gonna do your integration completely definite integral, like just the way it is, all the way to plus c. But except you get rid of plus c and you just change the boundary 1 and 0. And that's the best way, because you're gonna have some part, you're gonna say, well, where do I plug in 1 and 0? You just do it all the way to the end after you do all the definite integral. And then you plug in 1 and 0. So this one, remember, we talk about, this one has a 1 in the front. Why is 1? Because the natural log of x and arc sine of x, arc tan of x, you need to think about they can be alone by itself too. So you can integrate by alone by itself. And later we're going to talk about one of the harder case, which is, that one is for sure not AP exam, but for sure not on my exam, but I still have to show you.
I got you one, wait, A, U prime over square root of one, U squared.
How much shit we got now?
Oh, yeah, I did.
What's the other?
Same answer.
Oh, you
You're late to your one minus right?
Oh, it has PJ's over soon. No, because the integral is the integral of F.
We need to get back to the original
Yes, the original equation, which is, oh, sure.
Why do we stop on this one? Why do we stop on this one?
Because it's integratable.
It's integrable, yes. When they multiply together, it's integratable, then you stop.
The third line.
No, the second line.
Can you explain integratable again? It's like where it's like horizontal. You can take it.
So if I would have said this one as a sine inverse of x, right? And this one is going to be 1 over root of 1 minus x squared, right? And this is the 1, right? And what integration 1 is not x squared, you dumbass?
I meant to say X.
That's on live stream. Okay, so do you realize actually second line is integrable? Look, this is integratable.
Okay, why is it integratable? Because you can take the
Because you can do it.
What? You can take and you can take use of one. Why is it integral at the top? Oh, stop.
All right, so this is the x sine inverse of x. So that's the first thing. Second thing is minus integration of x over square root 1 minus x squared dx. Now remember, I don't put a boundary here. I don't put a boundary until I finish all the integral. So that's going to be x sine inverse of x. And this is going to be u substitution. So I'm going to write it on the side. 1 minus x squared. du is equal to minus 2x dx. And du equal to negative 2x dx. So that's going to be integration square root u, x, and then du over negative 2. And this is minus. X, sorry. X is going to cancel out. So x is going to cancel out here. So that's going to be x sine inverse of x minus plus 1/2 integration to u to the negative 1/2 du. Is that okay? That's equal to x sine inverse of x plus 1/2 u to the 1/2 times 2 plus c. So that's equal to x sine inverse of x plus u to the 1/2, which is square root 1 minus x squared between 1 and 0. Don't forget now we're doing definite integral. So we're going to plug in 1. So it'll be 1 times sine inverse of 1 plus, if I plug in 1, 0, minus 0 plus square root 1. So what's sine inverse of 1? Pi over 2. And then minus 1. This is my final answer.
What is arcane 1?
You want to play the game that we designed?
Great.
You can play against the bot. Can you? Okay. Does this make sense?
Yes.
You do the definite integral all the way to the end because you have to integrate all the stuff, finish all your indefinite integral, and then you do the definite integral, and that's going to be a part. Now, I'm going to show you that this question is not going to be on the test, but I'm going to still to show you that it can push a lot of things to the limits. If we can push this thing here, is how do I do secant square of x, secant to a cube x dx? Okay, so secant cube x, you have to think about it a little bit differently. So when you choose your DI, you have to be careful. What should you choose for D and what should you choose for I? It's actually, you want to think about what I should be, right? Yes. What do you think?
Can I be secant squared?
I secant squared. Why is I secant squared?
Because secant cubed is just secant times secant squared, and so secant.
But why can I be secant?
Yeah,
Why do you choose secant squared?
secant squared can be integrated into easily into tan.
Right. So this one is gonna give you a secant square of x. And this one is gonna be secant of x and a plus minus plus. So this one's integratable is 10. And this one's derivative is gonna be sexy 10. Now, surprisingly, is this one's really hard to recognize when to stop. But you should know why you stop, because derivative secant of 10 is going to be even more gross. And derivative tangent is going to be secant square, or integration of tangent is going to be natural log of negative natural log of sine of x, which is also gross, because you cannot, then that means you're going to be gross and just, your next line is going to be very gross.
Is it gross?
Yeah, just gross. Okay, so then you say, well, I'm gonna stop right here. Just pay attention. If I stop right here, then I'm gonna write out that it's gonna be secant of x, 10 of x. Is that okay? Minus integration of secant of x, 10 square of x. And then you say, wait, I don't want to make it more ugly, but I know what's tangent square of x equal to. This is equal to something else. No, it's not cotangent. So I can do it on the side, sine square of x. Shh. You guys need to familiar with this because it's gonna occur on the next situation. So I'm gonna divide this by cosine square of x, right? So that's equal to 10 square of x plus 1 equal to secant square of x, right? So what's 10 square of x equal to? Secant square of x minus 1, right? Now what we're gonna do is we're gonna do a little bit. We see something though. We see something. I'm telling you, see something.
This is the math we used to do in elementary school. Middle school math.
Do you see that there is a secant cube occur again, which is the like term? I can move that particular term to the other side. So that's going to be 2 integration of secant cube x dx equal to secant x 10 of x plus, which is, we know that integration of secant of x is going to be natural log of secant of x plus 10 of x plus c. Then all you gotta do is divide it by 2, and then you're done. And then integration of secant cube of x dx equal to secant of x 10 of x over 2 plus 1/2 ln of secant of x plus 10 of x plus c. And this is the final answer.
What's the word again?
It's cool, but it's like.
No, I won't test you. I promise you I won't test you. But this is a yeah, because you already find the integration secant cube. You already find the integration secant cube. What? didn't know what you signed up for. If you would have known this, you will not sign up for this class. You what?
I need to make an ultimate trigger. Every other time
Yeah. But so, I would like, because we had problems with what we played. What we played
Yeah.
Darren's helping you. I don't know. I also said blind. I also said
Blind leading
Brandon also said next to me. Brandon.
Okay, I gotta climb the unit circle and then I gotta.
I mean, do you want to tell me which ones they are? When I get home, genuinely, it feels like I get knocked out. I just like
You get knocked down.
I just like stop working, bro. My brain is like fried. Like,
Okay, so make sure to people says solve by simplest math and not require integration by part. Not all questions require integration by parts.
okay.
So make sure you told people that. So it's gonna be 11 to 37 and 49.
All of them?
Odd.
Odd.
Good question. All of them? Now, if they don't know how to do a question, they can skip. So skip it and come back if you figure out how to do it. Don't stuck in the question. Don't get stuck in the question. Did you take a picture of the stuff?
Is all.
Yeah. So just from here to here, odd, and from here to here, odd.
Okay, I got you. I'll send it next period.
Okay. Right.
Thank you. Scrap. Really? Oh, okay. I thought they were the platform scrap. Have a good day. We'll keep you
Bye.
updated.
I'm gonna come back. I'm coming back.
Yeah.
I actually enjoy this because I think we should host a club like this, just solving problems. And you solving problems, you learn so much stuff.
This is really complicated shit, Missy. I know, like.
But you learn stuff while at it.
Yeah, I did learn most.
Yeah, because the thing is it's like I feel like high school is so useless. Not even like anything. Even calculus, I feel like it's useless. Even I teach it. I just think it's
I
fun.
like the main, like,
I thinking about critical thinking skill, yes.
yeah, like, it's the only thing it's supposed to teach you is how to study and how to think, like, critically.
Yeah.
That's the only thing that it doesn't teach
But
you.
I don't feel like college, like I think high school should be strictly AI now.
Strictly AI, no.
No. It's like you have to get like good students, especially because in China they're doing that. After 12-year-old, they teach you AI.
I think we taught how to use, but not, like, only use AI. Because you see, the problem we have is because AI is such a limited source. And, like, if this was Matthew coding it, he could finish it in 2 hours, and we would not have the problems with this AI.
Oh.
AI, there are different situations where AI is better than humans, but I think they should know how to use AI. That's the issue. I'll be right back.
I am tough. How is that? I am tough.
He didn't even say anything. Everybody just like does their own grade, and Reggie just didn't say anything.
Stupid.
No, yeah, everyone does it. That's what happened with everyone just does their own grade and friends won. Dude said that again.
That's why I need to go.
Yeah, but you guys ready? Okay.
Yeah.
Let's do it.
Thank you.
Write something stupid. Like I know it.
Or we just get down like this right now.
1 minute 33 seconds.
Dang, son.
What? You're such a liar.
Something is wrong. Or else.
You got it. It's clicking. I didn't write it.
Huh?
In a minute.
Is it white kid?
It would like pop. Yeah, it was like.
Have you done writing the writing?
Now does he do any more? I'm gonna ask around, see if this kid.
I have no idea. I understand how the people are actually useful. Like my friend, he showed me some like problems like. Have you watched Artist Supreme?
Yeah, I already told you it sucked.
You think it sucks?
It's a horrible movie.